in the back? All right, excellent. So I get to, I'll do the dual role for this talk since I'm the session chair and also giving a speech because I figured this is probably one of those topics that there's probably only one session chair in the world who ever would have approved, and I'm going to use the power. So my name's Darin Kinion. I'm also sometimes known as the Stig for my avatar on the forums. I have multiple pages now with forum responses. If you look for the word regex and put my name in there as a search, there's a scary number of results. So I want to get a little reg exercise in today, and I want to talk a little bit about how we do some text processing in LabVIEW. And so I'm going to talk about the string matching tools that LabVIEW gives you, and LabVIEw does provide you with a lot. In particular, the ones that I would assume everybody's seen at one time or another, simple match pattern. And once we get our warm-up stretching out of the way, we're going to dive right into our exercise for the afternoon, and that's the match regular expression. Some fun that you can have when you have regular expressions using search and replace, or as I'll talk about, I call it seek and destroy. Some of the implementation details of how LabVIEW is actually implementing these regular expressions and how you may want to eventually, when you sort of had enough of the Kool-Aid like some of us, want to go a little bit deeper. And finally, perhaps the most important lesson that I'll save till the very end, and sort of the ironic one, is how you actually avoid having to use these things in the first place. So that'll be my lesson to you at the end. And so this is a LabVIEW audience, so wait a minute, why am I talking about text? And you have to face it, you can run from text with LabVIEW, but you can't hide. And so there's a lot of places where we run into this sort of text processing. One is we provide user interfaces, and on those user interfaces, sometimes you're asking people to enter something like an email address. And so you need to know what were the contents of that email address. Did they enter a valid email address? I'll give you a little hint. Sometimes it's very nice for your user interface if you can actually validate these inputs in real time. And so, you know, it's nice to know as soon as somebody is like typing in an email address and it's an illegal character, usually you think of it as something that you don't know until the end, and it's hard to match until the end, but you can actually use tricks to sort of validate inputs as you go along. Sometimes it's phone numbers, URLs, emails. There's all kinds of crazy human input that we deal with that we'd like to get information out of. Sometimes it's, you know, it's configurations or something else, and we have to get this into a standard form that we can process. Data acquisition, we all know this. You're going to read those old data files that somebody, not us, we wouldn't make these kind of mistakes, but somehow there's somebody out there who keeps using multiple mixed delimiters in their data files. They keep mixing, you know, there's a hex here, there's decimal somewhere else, you know, so somebody has to read those files. And sometimes, you know, from these logs, you need to know just a piece of information. You need to know like a date. You need to know certain values. You have a couple things. So you're going to go in there, you're going to extract information from these old data files. And sometimes things you do just for fun, you're getting information from the outside world, either text files that lie around. You can actually get information. I've done a lot of forum statistics in the past where you can actually scrape the HTML for interesting data. And hardware, when you've been around a lot of hardware and you start to say like, oh, you ask for how something's configured, they give you back some crazy string, and it seems to be something that like, everyone has its own particular favorite response. So a lot of times you're having this text response, and again, you need to convert it into something that you can later deal with. And so some of the options that LabVIEW gives us, if you look at it as they scale with flexibility, there's of course always equals. That's about as rigid as you can get. That's exact equality, not much to see here. My only bummer with equals is it turns out if you really care about performance, if you're comparing two strings, LabVIEW won't tell you they're unequal until it actually matches a character that is unequal. So if you have two strings of different length that match out for the first, 1,000 characters, LabVIEW will dutifully like wait until it falls off the cliff instead of doing the old, oh wait, they're different length, not equal. It's like they carry around the length in the string, it's like, so some of us get bitten. One sort of small step above equals is now you can do like the simple true-false comparison. So here you're just matching the true string or false string. So you're just doing exact match again, but you're giving yourself a couple of alternatives. Search split string, actually, you know, it's kind of cool sometimes. Most of the time, you're just going to leave the character blank and just put a number here to split. Again, not very sophisticated. The first semi-sophisticated one you'll run into is the old scan from string, and that one can be very useful when you have a string and you want to instantly get out LabVIEW variables. This is doing exactly what you want a lot of times, with the caveat, and again, as you might guess, it's a huge caveat, that your input is well formed. And you know, that's not always the case. And in particular, if your structure is very rigid, like if you know you have an exact string followed by a number, followed by another like exact string, you can get away with this particular node. One of the things that can be sort of frustrating about it is, we'll talk about what it means, is the matches here are greedy. And that means if you tell it to start matching a string, it's just going to grab basically everything it can. It's not, if you tell it I want a string and a number, the string part's just not going to stop. You're going to be like everything, letters, numbers. And so then this, you know, to get around that, you start making patterns here that start looking just as bad as the regular expressions that people are so afraid of. One of the tricks I will talk about is one of the nice uses you'll see is to use the tools that I'll talk about later to clean up your data, so then it comes into a form that is very friendly for a node such as this, or like scan for array. Your first foray into what's called a regular expression is, of course, match pattern. I hope, you know, as most people here have used it. You know, you've seen that you start to get a few options. I'm going to talk about this a little bit. You start to use what they call a regular expression as the input. So you start to get a little more power. The main limitation you'll see is like it has to scan the string from beginning to end. It's going to look for a match. It's going to start from the beginning, march on through. Just one linear swoop. It means it's fast, but it's going to limit your flexibility. And then, when you reach the big leagues, you're going to get what we call match regular expression. And now, basically, the sky's the limit. You can unleash, you know, a very flexible language on your text matching needs. And as I'll say, I did have to leave off one of my favorites, the scan string for tokens. I love it, but you hardly ever use it, so maybe next year I'll have time to use it. It is a good one. But as you can imagine, I chose flexibility for this axis, but there's probably one other quantity that would sit equally well on this axis. You might guess that that's execution time. And so as you go up the flexibility curve, of course, the time that it's going to take you to process and make a match is going to go up. Sometimes that's a problem. If it's something that you're doing in real time, if it's something that you have to do a lot, you could run into problems. Sometimes it's not such a big deal because, like I said, a lot of the problems you run into is you're cleaning up somebody else's mess. So somebody has got some old files with some old crazy data format in there, and you need to whip it into shape. It would be silly to write a tool that like whips something into shape and then reads it. What you're going to do is you're going to clean it up, and then you'll always have your cleaner version to use later. So for some of these very tedious, very painful one-off jobs, you know, it's well worth it to use every tool in your arsenal. So let's look at the first one on the list, and that's our old friend match pattern. And so we've all seen the help. There's not too much that goes on. You have an input string, you have what they call a regular expression, and you basically just get out three components. What's before, what's the match, what's after, including the offset. And so this does introduce some very important concepts. So if you use this, you're going to be familiar with a lot of the things that you're going to see in the regex. The first thing that you're going to see that you don't have in the simple, rigid matching tools are what we call character classes, and these are alternatives. So you could say at this point in the string, I'm looking for either some type of simple choice. So instead of, you know, looking for an exact match, you can say, oh, right here at this position in the match, I want either A, B, C, or D. And that's already making something that's very flexible, much more than you can do with equals. You can often use shorthand for these ranges. You can put in, for letters and numbers, you can say, I want lowercase letters, which you can say A to Z, 0 to 9 for digits. Same for uppercase. You can say if you want uppercase letter there too as well. And also, it's one of the lessons that I'll probably try to remind you a few times. Along with these ranges, there's also what we have that's called exclusions. And so that's going to match something that's not inside the character class. And that can be a very powerful tool when you start thinking about things from the other perspective, which is, it's almost the Zen lesson for the day, is that sometimes it's easier to describe what something is not than to describe what it is. So a lot of times you can make things simpler for you to understand by describing something as what it's not. So it's like, if you want something that's not a number, you can say it, use either the caret or the tilde, and I'll hint just at the difference. One of those that few of us have probably seen, that if you use the tilde in match pattern, it means a displayable character, so like the lower ASCII set, not in this range. Whereas when you use the tilde, it's every character, it's all of the 0 to 255, except for what you put in there. It's a very subtle difference. And the only reason you start to run into it is because in the regular expression, everything is like the caret, and you start, reminding yourself, well, do I need a caret now because I'm using match pattern? Do I need a tilde? So it's like, when you start using both, it's easy to get those two mixed up. I don't use this so much. I pretty much mostly care about displayable, so I pretty much will always use the character as the exclusion. The second powerful tool that you're going to get, and we're going to use a lot of, are quantifiers. So now what you can do is you can describe how many of something that you want. So if you have a character class or a letter or anything, you can put a star after it, and that means you want 0 or more. Basically, it's optional, and you can have as many as show up in the string. So if you have a star and your string has 5 A's, you're going to grab them all. Or if it's 0, it's going to match. That'll trick you a few times when you get used to that. Like the star can be very tricky, because a match of nothing is still a match because you've matched. So again, these are little things that you get used to, but can be very confusing when you first start plugging these things in and figuring out why you're getting what you're getting. A second quantifier is the plus sign. And that means it's no longer optional. We need at least one, but there could be more. So if you have A plus, there must be at least one A, but there could also be 1, 2, 3, or 4. So not all possibilities. And the third is the question mark. That means there's 0 or 1. So it's optional, but there could be at most 1, or at least you're only going to take 1 in the match. So we have character classes, we have quantifiers, and the third and last piece in this regular expression language are anchors. And this is sometimes because you want it to act a little more like equals. Left to its own devices, match pattern, match regular expression are going to find what you're looking for anywhere that it occurs in the string. So if your string says a cat, and you're searching for cat, it's going to find it at an offset of 2 in your string. So what the anchors allow you to do is to not allow it to seek beyond the initial position. So if you put in an offset or the beginning of the string, so if you put a caret at the very beginning of your regular expression, it's only going to match if your regular expression matches at the start of the string. Likewise, if you put the $sign at the end of your regular expression, it's only going to match if your string ends at the same place that your matching expression ends. So in this way, and if you put them both, then it's near an exact match. So if you were to do something silly, like say, caret, cat, string, you're using equals at that point. So, but the capability is there, and usually it's like you'll see one or the other. And for this one, we'll talk a little bit about regex. This is always the string. Regex will give you the option to actually do line by line, so you can use these anchors line by line, not just over the entire string. So there's not too much to worry about with match pattern, but if there was one thing I would warn people about, that is to mind the dot. And because the one piece I didn't mention in talking about the regular expression language is that the dot itself is a special character. And it means to match anything, except for a new line character. They had to throw that caveat in there. So basically, it's match anything. So let's say you had a string that was some simple A, B, C, D, E, F, could be like a file name. And you're like, oh, okay, I know how to do this. I'm going to look for a lowercase letter, followed by a dot, followed by more lowercase letters. You run it, you say, hey, success. It matched. I got exactly what I wanted. And then, of course, you're going to do unit testing on your code, and you're going to put in now ABC, exclamation point, D, E, F. And you're going to run it, and you're going to say, what? That's not a match. I didn't ask for that. And so this is probably not what you intended. So the caveat, the way around it, And eventually, it starts to become, I wouldn't say it becomes second nature, but it becomes, maybe third nature. It'll bite you the first time, and then you understand that whenever you're dealing with the dot, you either have to escape it, which means putting a slash before it, or put it inside this character class. So if you give it the character class, the choices, and the only choice is dot, or if dot appears in there, this is going to be taken as the literal dot. So if you did ABC bracket dot, that would only match the one you intended. It would no longer match there. So if you remember to mind the dot, match pattern can be your friend in many situations. But when you start to run into trouble, and that's when you sort of move away from its butter zone. And the butter zone of match pattern is when you have a fixed number of very easily distinguishable chunks. If you have a bunch of letters followed by numbers, it works well. If, say, you're looking for something that's just simply enclosed in brackets, this can be very fast, very performant. But eventually, you're going to start to want to match things that have differing lengths. And the way match pattern works, as I mentioned, is it marches along your regular expression character by character. And so at every point along the line, it needs something to match. And so if you're doing something simple, like saying, okay, I want doghouse and birdhouse to match, you have to start constructing something that says, well, the first character has to be a D or a B. The second character has to be an O or an I. The third character has to be a G or an R. Oh, wait, the D, there could be one here, but maybe not, and then house. And you'll run this and it's going to work, and again, you'll start to think you declare victory. But then you're going to ask yourself, well, what does this do with big house? Oh, wait, that matches too. What about the bog house? We all put in the bog house. Oh, no, that's also going to match. Or the bigger house. All of these things are going to be unintentional matches. And so, that's something that becomes very difficult. And the second thing, once you start getting comfortable with match pattern, I start to see a lot of code that starts to look like this. This is just the beginning of what's going to happen. And you're going to say, oh, well, I know how to match this first part, and I get my match, and oh, well, now within that first match, okay, I need to start looking for something else. And then, oh, okay, within that something else, I need to start looking for yet something else. And pretty soon you're going to start having format into string, so you're going to take what you matched here, and you're going to want to tweak what you're looking for later. And you can imagine, I hope I can convince you that that's going to get out of hand very quickly. And this comes up, very real-world problems. Like if you have a chunk of HTML, and let's say you simply want to find the bold and the italic tags, and of course they may or may not be nested, you immediately hit the wall that oh, well, the pattern to tell you when you've reached the end depends upon which tag you actually started with the matching. So you're already starting down a slippery slope. And then you have to do like I showed you before. You have to go inside your earlier match to start figuring out what to happen. And so at this point in your life, you're really destined, the choice you make is really going to tell you which of two places you're going to go. And so if you're enlightened and you think there must be a better way, you could head to the regular expression board on Breakpoint. You can ask for help. People will help you along and give you a solution to your problem. If you're one of those who get scared off by regular expressions and think, oh, I can do this, then most likely you're going to be ending up for a slightly different place on Breakpoint. And that's going to be the Rube Goldberg code. And that's what happens when you start having, and it's too bad Ray, one of our esteemed champions, is not here. Ray, in particular, I have bumped from this board to this board. And I sometimes kick into this board so that I can then get him into this board. And so, the choice is yours. Let's dive into it. Let's get started with the real power when we really need it. And so now we're going to look at the higher horsepower version of match pattern, and that is the match regular expression node. Most of it looks very similar to what we saw in match pattern with input string, what most of us would now call the regular expression input. You get the same output with the offset. They just added errors. And they've added a couple of nice inputs that you can use. There are a couple options. Multi-line is now an option. And what all that does is that tells you what those anchor characters, and they'll be the same. All it tells you is how those behave. Like if it's multi-line, then you can start searching for matches that occur on a given line. If you leave this false, the default, then the anchors are only going to be beginning or the end of the string, regardless of how many lines are in there. ignore case is pretty self-explanatory. And again, I'm going to say that you have much more power and flexibility when you start using this, but just remember that it's going to be a lot slower than MatchPad. So we're not doing this for fun, we're doing this because you have to. And what gets you, like one of the things that bites you inherently, is when we start giving us the option to have these variable length matches or variable length alternatives, you can't just go through the string once. You have to go through it and check many alternatives. So that's an inherent price you pay for having the flexibility. And so now I've used the term a lot, so now let's sort of say, what the heck is a regular expression? This is there's a lot of ways people describe it. A lot of people describe it as looking like swear words when they see it the first time. Hieroglyphics is a word I've heard thrown around many times in regards to regular expressions. But I like to think of them more as like what we call a declarative language. It's a full language, and what I mean when I say that it's declarative, it means you're describing the results that you want. You're not trying to describe the implicit steps of how you get those results. That's what in a typical language, like in LabVIEW, you're telling LabVIEW the steps to give you the result that you want. But what you can do, you can think of as regular expressions as like a slightly higher level language. And you're not worried about it. You let the regex engine do its thing and make your match. What you're doing is you're describing the result that you want, the target. For people who worry about this, who care about these details, I'll talk a little bit about. LabVIEW implements a particular flavor that's called the Perl-compatible regular expressions, PCRE. They use a, let's say, not up to the minute version of the PCRE library. But nonetheless, this is a very highly used, well optimized library. And it gives you, in the regular expression language, everything we talked about with match pattern, the character classes, the anchors, the quantifiers, but a whole lot more. And some of the things that we're going to talk about that it gives you, grouping. So now you can use parentheses to set aside portions of your match. This could be a portion of the code or the text that you're interested in. If you're trying to get out a date, you can surround that part of your expression in parentheses, and you'll later be able to extract just that part of the whole match very efficiently. And so if you, and we'll see there's sort of two flavors. If you just use parentheses, we call those capture groups. You'll hear me say a lot, capturing groups. And that just means that the part of the regular expression that sits between these parentheses, you'll be able to get that chunk out directly. If you put a question mark here, you'll get what I demonstrate is a non-capturing group. It's used as a different role. It means LabVIEW, or the regex engine, looks at just that chunk, but it's not going to give it access to you later, and I'll show you why you may want to do that. Back references. So within your regular expression, you can very simply, by number or by name if you want, refer back to the results of one of these previous groups. So if you put /1 here, you can refer in your match to something that happened earlier. So like imagine that HTML example. If you have a capture group that's capturing the tag, the B that you started the match, you can refer to that part later with a simple reference when you're then trying to match the closing one. So you can say, I only want the closing one that matches what was down here. So those I'll show you some really interesting uses for. Alternation or alternatives now. So what the bar gives you is the ability to specify choices. So before, remember match pattern, you had to think character by character, what do you want the match to be? And if you wanted to say cat or dog, you had to do C, D, A, O, G, T, very painful. But with alternatives, you could say cat or dog, and it will do pretty much what you expect. It will either match the whole word cat or match the whole word dog. And we'll see some examples of that. And one of the reasons for groups is there specifically to call out what the alternatives are. So if you just put an alternation in there, it's one choice is going to be everything in the regex before it. This other choice is going to be everything in the regex after it. So if you want to break it down, then you're going to use a group. And you'll, again, don't worry, you're going to see examples of all this, but I have demos, so I want you to have a little bit of a flavor. Instead of just saying 0 or 1, 1 or more, you have full control over how many you want. you can specify a minimum or a maximum, so you can say at least 2, no more than 2. We'll talk about something else that's very fun with these, possessiveness, something that applies to the regex engine but not to us, laziness. And when you say it's a language, here you really go. Conditionals, you can put if-then-else statements inside the regular expression. So again, based on what's happened in the match beforehand, can drive what you want to match later in the string. Assertions, another fun animal. So assertions can be thought of as something that's just a check, but it's not going to become part of your final match. And we'll see examples where you would say, oh, I want X, but not if it's followed by Y. And so it's very easy to have your match say X, and then you put in a negative assertion and you just put Y here, and you'll match X and exactly as you want. If I have time, you can actually even use recursion, and it can be very interesting. I mean, this is really powerful stuff. It takes true regex ninjahood to start staring at it. I don't expect anybody to really get there today, but I just want you to know what you can do if you fully understand. And if I manage to get my job done for the rest of the talk, something like this is going to make a lot more sense to you at the end. Oops, my clickers stopped working. So before we dive in, we just need to look at the anatomy of a typical regular expression. And so let's just look at, a very simple example, because it's going to show something you'll see over and over again when you learn to look at it this way. I won't say all is going to make sense, but it'll make a lot more sense. And so what we have here is we have this regular expression, and let's break it down a little bit. So we have the parentheses here. So we recognize that as a capture group. We have the /D, and I'm going to describe these shortly. This just happens to be a shorthand, just an abbreviation, just to make things a little more readable, for a digit. So anything between 0 and 9. The plus means the same thing now. There must be one or more digit inside the group. Question mark means lazy match. We'll see what that means. But for now, you just remember that what comes here after the quantifier is just going to tell you if it's lazy or greedy. And what we have here is what we saw before. The 3 here means I want exactly 3. So what you do is you look at this crazy thing. It's not even that crazy. And what you do is you just say what it is you're trying to match. And you just say, I want to match exactly 3 groups of 1 or more digits. And so if you just learn to read it that way, then a lot of these things can start to make sense. And the common pattern you see is that there's a target, and this is a character or a class of characters. So you can look here and say the target is a digit. The quantifier is how many I want. I want 1 or more. And possessiveness, is it greedy or lazy? That's right here. So this part here is one of these units of target, quantifier, possessiveness. And it's wrapped in a second one, because this capture group now is your target. So I want a group. How many do I want? I want 3. There's no possessiveness here. Everything will default to being greedy. You could put a plus here if you want. But there's enough characters to come in to confuse you, so if some things can be left out, we prefer to do that. So when you start looking at that as these kind of blocks of what you're looking for, how many you're looking for, and possessiveness, you will, is there a question back there?
Yeah, does the question mark refer to a lazy match? Or does
Yes.
it refer to a quantifier of 0 or 1?
In this case, it's a lazy, so when it appears after a quantifier, so the question mark is being lazy always has to appear after a quantifier. So in this instance, it's a lazy match. If I were to leave this out, the 0 or 1, then it becomes so it's like, when it's the second one here, when it arrives in this slot, it's always going to be possessiveness, lazy, greedy, or not. Hate to do it to you, but there's sorry.
So it could be plus plus. The first plus would mean something different than the second.
Yes, exactly. That would be greedy, and that would be the default. And so we could even do that. You can sometimes do the test to see like what operations default greedy and what. So before I can get to my first demo, which I want to, we have to do a lot more things. And so now you have a bunch of different ways that your regular expression can match. And so we need some rules of the regular expression matching. And the first rule is that you do not talk about, match. I think I'm thinking of my other hobby. The first rule is actually that the earliest match wins. So that means of all the possible matches, the one that starts earliest in the string is the one that's going to be returned. And if you have more than one possible match that starts at that location, the longest of those is going to win. So we call this the longest leftmost match wins. So it becomes second nature. It's actually the intuitive way. Like if you were to guess as to how it would work, that's kind of what you would expect. I hope. I could be warped, but I could still be warped, and this could still be. So I'm going to get to the first demo, and the first demo is just going to use a few tools that we talked about, literals, the alternatives that we talked about with ranges, and some shorthands that, again, most of them hopefully make sense. So if you see things like /D, that means digit. And something that's very nice in the shorthand is most of them that you use have the corresponding exclusion simply capitalized. So when you reach that Zen state again, when you say, oh, it's easier to say what something is not, you're saying like, oh, I'm looking for something that's not a digit. And likewise, you can have a word character, which is basically an alphanumeric plus underscore. You always have to throw some loophole in there. So you can, if you're actually looking for that, you can use W, and again, for not. A lot of this grew out of grep and early command lines. A lot of these things we're thinking of like file names, and that's how underscore snuck its way in there. One of the things that will get you is that /S is for all white space, not the space character. That's going to bite you once or twice. That's just, I think, the cost of learning. You try to tell yourself that's not what's going to happen. You're always going to think that it's space when you put that in there. Not white space. So again, just remember, tell yourself it's not just space. There's horizontal white space, not horizontal, vertical white space. These become very useful when you're cleaning up these messes that people talk about. And you're like saying, like, okay, somebody's giving you a text file, and there's all kinds of crazy tabs and spaces in there. You're trying to, so you're just like, don't try to guess all the combinations they use. Just say, like, look, I'm looking for one or more consecutive horizontal white space, and that will be your match.
Darin?
Yeah.
It's just a string there. What was the definition of vertical?
New line and return, yeah. And some old ASCIIs have what's called vertical tab. So those would be the three characters that would land. Yeah, a lot of these things get simplified, and a lot of the regex get simplified because in LabVIEW, everything is working just on ASCII strings. When you start, the same engine can actually start to handle Unicode, then there's a lot more fun and a lot more power. So let's get to our first demo here. And this is just going to be like, we're going to talk about lazy and greedy. And what I'm going to show you for all my demos, whoops, that's not mine. Enough of it. Now I have to work on the second monitor. So this is a tool that I wrote years ago that sadly doesn't fit on the second monitor with the crappy resolution. I call this one the regex helper because I could never remember what all these characters were. So you could actually build your regex not by remembering anything, but by selecting what you want to match. And so I already have this one preloaded with our first example. And that's, we're going to look at the string LabVIEW 2016. We're going to apply this regular expression. Oh, wow, you can get to see the results. I give away the punchline already. So much for testing. So what we're going to look for is the dot, which is anything. We're going to look for that star, so 0 or more. We're going to be lazy about it. And then after the anything, we're going to look for 1 or more digits. And so as I test this guy, like, the result is shown here. And so the way that you can read the results is anything that gets bold, everything that's bold is part of the match. Everything that's underlined is going to be the capture group. So you can see that LabVIEW 2016 was the entire match. And we got 2 pieces. We got everything, and then we got 1 or more digits. And so the reason we got this particular result was a direct result of making this guy lazy. And so when we say it's lazy, we're meaning this anything is going to want to match as little as possible. It wants to get away with 0. Like, it would prefer to match nothing. So if this guy matches nothing, then when you get to this part, it says, oh, you're not a number, no match. So you're just like, so this guy says, oh, okay, I'll have to capture one character. And then you check again, and it still fails. And so that continues until you reach this point. And at that point, the dot contains LabVIEW, and the capture group now contains your number. And so this is kind of the natural result that you would kind of expect to see when you're thinking of like anything followed by one or more digits. If you leave the regex to its own devices, you're going to get what I was going to show you as the unexpected result, which is what happens when I get rid of, so it's going to default now to greedy. So now we're going to do the same thing, except now the anything is going to be greedy. And so greedy might imply exactly what you would expect. So you see what happened now was this guy was very greedy, so it wanted to match everything. It tried it, and then this part failed, so it's like, okay, if I have to, I'll give you one character left over. And so now when you leave it that one character, it can be a match. And so that's why the submatch now is just the last number. And so this is what we mean by greedy or lazy. That's just how aggressive this part of the match is. And that can be used to your advantage. Like it could be that you literally want the last digit or maybe the last two digits, and you can tweak that. You can let that be greedy. Or it could be like what you kind of want to see, which is you want to see things that aren't digits followed by that. So that's just like the simple thing that we mean by greedy versus lazy. And so the second, so the second thing I want to show you is, oh yeah, that's the help. Also built into my tool. There's a link to where you can get this tool on the website. Is, oh, now I gotta get back over here. So what I can do is I can load. Now, right. I wish I knew how to turn on. So now what we're going to do for this example is we're going to match a bunch of different numbers. And what we have down here for the test are a whole bunch of different formats of floating point numbers that you might want to find. You want to be able to find any of these varieties. And so you can actually do that in a relatively easy and straightforward fashion. Get rid of what's in there. Let's go to my handy dandy macro. And so you're going to sort of spell it out exactly how you would think of what does a floating point number look like. Well, there's a 0 or 1 sign that's on there. There's one or more digits after the sign. There may or may not be a radix point. The first ones are integers. There are going to be more digits after the dot. And then you get to something that's kind of interesting. You know, this is sort of the first thing you start to build up, is what happens after, what can you have after the numbers? These numbers may or may not have an exponent. And so the regex is sort of constructed here as this entire group represents the exponent. And the question mark means it may or may not be there. If it happens to be there, and this is the example of a non-capturing group, it's just, I don't need to refer to the exponent part. It's going to start with an upper or lowercase e. There may or may not be a sign there, but there will only be at most one. And then there'll be some digits. That's what the exponent looks like. And so this entire exponent either is there or it's not there. And so we can test this. Auto scroll works. You can still see that so match the decimal. I'm hitting to go to the next. So this will scan in the entire string, and it'll show you in bold what matches. So it matched negative to integer. You can go to positive sign, decimals, positive or negatives. You can see you got the exponent without a sign, exponent with sign, and at the end. So you can actually, like, have the full resolution. You can see that there's no longer matches. So again, yes.
What's the question mark colon doing again?
So that means that this particular group with the exponent is non-capturing. So that means I don't need to get it back out afterwards. It's just there to refer to the group that is the exponent section of your number. So.
Darin, if you didn't have that, then it would like show up in red.
Yeah, exactly. Yep. Yep. And usually, you just leave it on. Usually people just like capture everything. Because like I said, one of the things you'll learn, there are enough characters in there to decipher anyway that you can get away with it. Sometimes it becomes tricky because if you start using back references, to know the number, if you start having these just random groups in there, it'll screw up your number. All right.
What's the benefit of having the parentheses or the exponent?
Because the entire exponent part may be there or it might be missing. And so there's no need, like once you decide that what follows your number isn't an exponent section, forget it. Otherwise you're like, oh, there may or may not be an E, may or may so. It's just a way the group can fail and it makes things a lot faster. So we saw lazy, greedy. We saw the grouping that I talked about with the parentheses. We saw the non-capture group. And I'll point out that the capture groups are the ones that if you take the match regular expression node, as you've seen, you can actually pull it down and get the outputs. These submatches are returning any of those capture groups that you put in your regular expression. So that can be very useful. Like if I wanted the exponent, it could be pulled out into one of these subgroups to know that. So this one we already did the second demo since we got 2 for the price of 1. Now let's talk about the next fun. This is something that you use quite a bit, and it builds upon the capture groups. And that is a back reference, which is, as I alluded to before, you can now have choices made in your regex depend upon what happened earlier based on the results of an earlier capture group. And so you can do this in like 3 different ways. You can just use the shortcut /number, where number is the capture group, so it goes by 1, 2, 3, et cetera, in your regular expressions. You use /1, /2, /3. You can do a relative reference. This becomes more reusable. So you could say, like you said, /-1, then that's the first prior capture group. And so sometimes that's a lot more reliable if you start copying and pasting these things to know where it is relative to where you are within a regex than to know where you are from the beginning. One of the things LabVIEW doesn't give you full support for, but if you just want to use it inside the regex, you can also name these capture groups. And this is very useful in regroup. So if you give your group some p equals name and then carry on with your regex, you can refer to that later by name. And that way it doesn't matter where it sits in the regex, what happens. You have a nice, but again, you start polluting your regex as it starts growing exponentially. And so just to show you that there's no limit to what you can do, what I've talked about here with /number, /-number, this is referring to the result of that earlier match attempt. You can also repeat the test of an earlier capture group with what we call a reference conditional. And I'll show you how that comes into play. So you just use a slightly different syntax. And again, if you're using a tool like my helper, you don't have to remember what this is. You just pull it down from the menu, put it in, and then add it, and it will give you the. But if you start using these conditionals that I talked about, then you can have something tested and tested again. This can make something a little. If you have, like, let's say you broke through blood, sweat, and tears, you have a regex that matches something, and it works, and you want to do that same test later on, you may not want to see that huge blob twice. So what you could do is the second time, just refer back to the first one. So you can have a much more compact expression that's a little bit easier on the eyes. Alternation, I think I even talked enough about. I think we would understand it from how I described it in the intro, which is by default, your choices keep going either until you hit the end of the regex or you hit a parenthesis. And like I said, if you really wanted cat dog or kadog, you could actually just have a single character alternative like cat and dog. Not that you'd ever want to, but that's just the behavior. And so let me get or with no PowerPoint, so I can put it in single. I read it out. Being stopped. I don't know why LabVIEW won't pop the file browser on the document on which I so conditional clear this. Start with backgrounds. Whoops. That's not So what I wanted to match this one. This is describe a couple of the demos and then get it out of the way at once. Come back to that one. So the second demo I'm going to show you is we're going to actually ask to match the word hello either by itself or inside of brackets. And so the bad matches, the matches we don't want to have happen, are hello but not enclosed in brackets, or hello not starting in brackets, or a different word enclosed inside brackets. Sorry about this. The hard part of the regex is easy. Getting these it's still extending. Tim's not even here to do this one. Yeah. Okay, all right. Now, here we go. You can actually see what's going on. So, we are going to want supported technology today. So we are going to want an optional group that has the curly brace. Hello. And then what we're going to want All right, now we actually get to the demo. I wanted to found the right combination here. So what we have as our input, sense and sensibility, response and responsibility, and sense and responsibility. And so what we're going to match is our first capture group is either going to start with sense or response. Then we're going to have and we're going to look at this in two different ways. And so the first way that we're going to look at this is that did this first, we're going to repeat the first capture group. And so we're going to ask. And we found sense and sensibility. I'm going to look for the next match in there. Response and responsibility matches. And in fact, this time as well, sense and responsibility match. Because what we did is this particular repeat here, because it's a conditional reference, not a back reference, repeated this first group at this point in the match. And so I can quickly go in and say, well, what happens if I want to match I don't want to repeat this capture group, but instead I want to reapply the result of this one. So I just make that simple change to now a back reference. I test sense and sensibility. You see it matched the same thing twice. Response and responsibility, again, it matches. And then if I try to find the next match, oh, there are no longer three matches, because now what we've done, instead of reapplying this part of it, we've simply referred back to the response of this. And so that's actually a very useful tool for things when you're trying to do like bracket matching or things like that. Moving. I have a feeling it's PowerPoint that messes with all my display things every time I put it on there. So the next thing I want to talk about is we have conditionals, and it's another word that you're going to see. These are what we call assertions or lookarounds. And what they allow you to do is to examine what's going on in your text, either prior to or after your present location, without actually consuming any of the text into the match. And so they're sort of similar to what we saw as anchors, where like when you put an anchor there, it says like, oh, if it's the end of the string, then the match is okay. There's two syntaxes that you'll see. You're either going to say the positive one means you put a question mark with an equal sign, and then you put a regex here. And so what that's going to do is that's going to look ahead, forward in the string. And so for example, I showed the negative one. And so this is actually, if you just put the not here, then this means what we call a negative look ahead. So if you have x, what you can read this part as is x when not followed by y. So y in this case is not included in the match, and it's a much nicer alternative to just be able to peek ahead in your string a little bit and not have to include y in the match, only to toss it out later. Likewise, you can actually look backwards into the match. And so if you put the less than sign here, so you can look backwards for a regex that's equal, or backwards for a regex that's not equal, and we call this look behind. So for now, if you look at something here, you would read this as y is going to match only if it is not preceded by x. So in this case, when you get a y, it's going to look backwards and test to see that it's not x in front of it. It's kind of funny that you have to put the look ahead first, but that's what this is doing. And the match itself is only going to be y. You won't see this very often, and the reason is because once you've reached y, you've already consumed everything up to this point. And there's a second shorthand method that uses a capital K to reset the match. And so what you can do is you can say x, reset the match, y. Gets to the same place now, and this K is going to toss the x. And once again, your only match is only going to include y, the part that you're interested in. And so these assertions you're going to see in two places. One, you can use them alone, like I saw here. You just put an assertion in your regular expression, and that's going to cause total failure or success on its own. Or, what's very nice is if you have the conditional statement, the if-then statement that we'll talk about, you can use this assertion as that conditional. And so you can say, if I look behind and see something, then do this, else do that. And so before I demo that one, I want to use a different function here. So it's the close cousin and the very good friend of match regular expression. That's search and replace. And so that means like when you found something in your string, let's do something about it. And there's two flavors of search and replace string, and they only are sort of differentiated by this tiny little star that you see here. But this tiny little star turns on the power and lets you use regular expressions inside your search string. It's sort of the same difference between having match pattern and match regular expression. And one thing I will point out, again, that I see a lot is this replace all input. Don't forget about that one. It's very powerful. I can't tell you how many times I've seen this function sitting inside of a loop where people keep repeating until, like, oh, okay, there were no more replacements. So just tick replace all. You have a very clean shot. It's all done in one time. And what's very nice in regex mode is you can refer to the capture group that you have in your regular expression in the replacement string by using the $ followed by the number of the capture group. And so this can be very powerful. And I often use this in the mode that I call seek and destroy. And what that means is, again, from what I tell you about what is something not, sometimes it's easier to match the things that you don't want inside your text than it is to try to find all the possibilities that you want. So what you do is you do a seek for whatever it is that you don't want. It could be multiple tabs in a row. It could be multiple commas in a row. And then you can replace it with either nothing, which is what I call seek and destroy, which is usually like find all the garbage, just get rid of it. Or sometimes you would find multiple commas, and where those were, you would clean it up and say, I just want one instead. And so and you can make it very general, and you can say, like, so maybe your capture group tells you what delimiter was used. Then you can replace that with one of whatever it was that you found. And so that's why I call this one seek and destroy. And so the demo I'm going to show you using search and replace, assuming that my computer behaves itself, which I think it will, is we're going to format a large number to add commas. Because, you know, sometimes in your user interface, you're displaying like a million or something that's a couple million, and people are getting used to seeing commas in every part. And so the question you have now is, like, how are you going to describe the locations where you're going to put the comma, remembering that search and replace is going to start at the left and march its way to the right. So you always need to know what you're going to look for. And so there's really, it comes down to, there's two conditions to do this. So to the left of a location where the comma is going to be, you know there has to be one or more digits. You know, the number's not going to start with a comma. There must be one or more digits to the left. So we're going to look behind for one or more digits. To the right, now you start to see some of the tricks. You know what you need is you need a multiple of 3 digits, because you know that there's going to be a comma there. If there's 3, 6, 9, or 12 digits. With those digits followed by a terminator, which can either be the end of your string, the break, which means the end of the word, or it can be ended by something that's not a digit. So you need the multiple of 3 digits followed by your terminator. And so how do we describe these things? Well, a multiple of 3 digits we would describe as one or more groups of 3 digits. We know how to say one or more groups of 3 digits. So this is the group of 3 digits inside the parentheses, and the group, and this plus tells you we want one or more of those groups. And so the result for what we want to the right of a location is a group of 3 digits followed by, in this case, I'll just say the end of the string. And so what's interesting and unusual about this situation is now we're going to replace in these locations. So we've used 2 so-called zero-width assertions. So we've matched nothing. We've described a location where nothing currently exists in between 2 digits. The match is empty, and we're just going to replace this empty location with so now that this is just one, so I'm just going to drag this out into the turned out how it's bugging up my. And so now what I have is a long string. I have that regex that we talked about before. It's just for any place I'm going to look behind, look ahead, what we're going to replace it with. And I'll show you the block diagram here, which I want you to immediately flush from your memory banks after you see it. And the reason I want you to flush it from your memory banks is because what I've done, just to show you, is I've gone and put that search and replace inside a loop. And the reason why I did it is I just want to show you the intermediate values of what's going on during this match. So now that you've seen it inside the loop, pretend like that never happened. And so now what I have is I have this digit, I have the search string, I'm going to run it. Voila. So what you can see is as it marched through doing the replacements, it correctly found the first place because it saw 6 digits after and 1 digit to the right. Got to here, saw at least a digit to the left and 3 digits to the right. And the loop ends, of course, when there's 0 replacements. So this is a very simple, relatively powerful tool that you could then make part of your user interface now that any string that you want to display in this fashion just gets passed through search and replace. Easy thing. You do the same for hex strings where you want to put spaces in between multiples of digits. And so just a couple words now, like this is, I mean, you've just been like punched in the face with the syntax, and I'll stress again that if you go get my regex helper tool or one of the alternatives, you won't have to remember any of those things. You'll just say, I know that I want to look ahead, and it will build it for you. Because I find when I can recall these things easily, I've been staring way too much at a regex. You know, this is something that you only use once in a while. If you find yourself having too many of them memorized, you know, step away from the keyboard. A couple things, like if you are looking to take it in a little different direction, LabVIEW implements this as an X node. You'll hear a lot more about that tomorrow. Same bat time, same bat channel. And if you go in and you get the so-called ability VI behind that X node, what you can have returned is, instead of all the strings, sometimes you might be interested in just where those matches occurred during the string. So for example, in my demo, my regex helper, you might be surprised to know that one node that does not appear inside my regex helper BI is match regular expression. Nowhere do I use match regular expression in there. What I use instead are just the offsets that it would have given me, and that's what I use to go in and color and decide where the different matches are. And what you get is an array, and the array is start-stop values for all the individual submatches. And so this is actually, when it comes in handy, comes in very handy, and it's execute offsets. And again, if you download my helper, you'll see exactly how you can use something like this. You can, if you want, build your own library from the same PCRE library. The API is pretty straightforward. You just have to look out for 32, 64-bit issues. Why in the world would you do this? Now you're adding a call. There's a couple reasons. You can use different options than what LabVIEW gives you by standard. If you find yourself using Unicode, you can actually compile in options to let you put in white space that gets ignored, that makes things, because part of the problem with regexes is like it's this wall of characters, because if you put a white space character in there, it's going to take it literally. You can actually compile it with an option to like ignore that, so you can have nice formatting. And the second important reason is like, there are two reasons why match regular expression is so much slower than match pattern. And one is the complexity that we talked about and the power that you see. And the other is that in the LabVIEW implementation, LabVIEW will compile that regular expression that you put in there, and then it will execute the match. And if you have the same match applied over and over again, say in a loop, that's a very needless cost that you're paying every time to do that entire step. So if you break it out and you build your own API, and that might come eventually if I see if mine is ready for prime time, you can break it up. You can compile your regular expression, and then inside your loop, you only execute it. And it will execute substantially faster minus that compile step. And so that's an important reason why, if you have somewhere where you sort of still, you need the flexibility and you need a little more speed, one way to do it is to roll your own. And as I alluded to before, we'll call it a bit dated, the one that you can find in there. Another reason you may want to is you can actually extract these groups by name, not having to keep track of the relative number. That's actually a very nice feature. If you start doing this a lot in the beginning, not something you would worry about. And the real reason why I started doing this was what I call partial matching tests. So this, you can imagine, if you have a user interface and you want to know in real time, is an input okay before you start like blocking a key press, you can do what's so-called partial matching, which means if your match is failing because you've run out of input, but everything input so far is matching, you can consider that a partial success. So if you're matching against a phone number, you can know in real time that what they typed in so far would match a phone number in the end. And then you don't have to wait for everything to be banged in there and then say, oh, sorry, you screwed up, and try to erase it. You can actually start giving real-time feedback. We call it input validation. And you get this feature. You can enable that if you go in and use their API. It's a capability that LabVIEW hasn't added yet. And the third one, if you're really glutton or adventurous or fun and you want to just combine two things that go together like bread and butter, why not combine .NET and regex? You know? I mean, you become my hero at that point. Yes. If you are so inclined, it's actually not so bad. You can find the constructor method. If you've done it once for any type of .NET node, you find it system text, regular expressions. There are a couple features that I've grown to like about the .NET flavor. One of them is what we call balanced group matching. And so you can have a capture group that you can actually think of as being created and destroyed as you go through the regular expression. And so say that was a parenthesis. And so the group is created when you match an open, destroyed when you close. And so in that way, you can actually match things like parentheses, brackets, things of that. And because you know, at the end of the match, if the group has not been destroyed, then it was unbalanced. And you also know that if the internal count goes below 0, then the string is unbalanced. So I'll show you just a quick demo. I'm not going to show you. It's just going to be like the tease and to show you recursion. And then the other thing that I've kind of grown to like is, again, for my Zen-like thing of saying, looking at something as what it's not, you can do what's called character class abstraction. So you can say, I want A to Z, but not the letter Q, because I don't like the letter Q. And so you're allowed to do simple combinations like that, where otherwise you'd have to be doing something like, oh, I want A to P and R to Z. But you can actually rule out, and these can nest, but you know, if you ever have a a reason to do that, then I'll show you the demo. Actually, I'm not going to fight. Believe me, you can do it. You'll see it on the. It's actually pretty cool. Yeah, if there are quick questions.
Yeah.
Yes.
We're 11 minutes over.
Yes.
And there's another.
Who's the
some
session?
of the other sessions start in 4 minutes. So
All right.
If you want to go to the other sessions.
Yes.
Um,
Where was my timer? Yes, very good. But while they're